All right, good morning, Algebra 1 students. It's almost noon. I'm getting kind of a late start. I had some computer issues to deal with, but never fear, we are ready to go. Want to remind you that your assignments, as far as assignments go, your Canvas assignment is due tomorrow, okay? So get in there, click on that, get that turned in. And your Alex assignment, though, is not due until next week. Okay, progress reports will go out next week. So hopefully y'all got your stuff taken care of. Okay, so let's get to some problems. I want to get my whiteboard up here and get started on some things that I hope will help you out a little bit. Let's see where we're at here. We've done that problem. We've done that problem. Okay. Let's do one of these because this looks kind of fun. If that's all right with you. Yeah, let's do one of these. This is where we're getting some excitement here. Okay, so our directions are basically to solve, right? And so again, first thing we want to do, get rid of the parentheses. That's always step one, right? So we got to do the distributive property there. So this stays the same. But now I have another 5W here. 5 times 5 is 25 equals 35. Now I want to combine any like terms in this equation on the same side of the equal sign. These are like terms. The 25 is not a like term, so I cannot combine them. So I'm going to combine 5 and 5 and get 10W plus 25 equals 35. And now I can start doing the opposite. Always do the opposite, not always. Most of the time we do opposite of addition and subtraction first. Now I have 10W equals 10 because that added up to 0. Divide by 10, divide by 10, W equals 1. Okay, doing the opposite. Once we get those things simplified, right, this was all simplifying using the distributive property, combining like terms. Then we did the opposite from here on out. Okay, this was the opposite. All right, so that's a good one to know. Let's see. Let's see what this one looks like as we're getting into these harder equations to solve. Okay, so let's do a similar one here. Negative 8x minus 4 is equal to negative 6x plus 26. Okay, so again, here's my parentheses. Got to get rid of them with the distributive property. So negative 8 times x, negative 8 times negative 4, and then this side just stays the same. Now, remember this, splits the equation into two parts, right? Well, I don't have anything I can combine here. These are not like terms. I don't have anything I can combine here. These are not like terms. So now I can go ahead and start doing the opposite. Okay, so I'm going to do the opposite of adding 32, which is subtract 32. But I do it to the 26, right? I don't do it to the x because they're not the same. All right. Sorry. 6x. And this is negative 6 now. Now, I also need to do the opposite of this guy because I want to combine it with the negative 8x. So the opposite of that is add a 6x to both sides. So I get negative 2x equals negative 6. Now, for those of you that are kind of starting to figure this out, there's other things I could have done first here. I could have added 6x. I could have added 8x. I could have subtracted 26. Just you have to do the opposite, but the order doesn't really matter when you have two variables, one on each side. Okay, but it does have to get done. And my last step here is going to be divide by negative 2 on both sides. And so I got two negative signs. So x equals 3. Okay? So remember, you can always stop, pause, rewind if you would like. Okay, next up, we're going to go one step harder. Okay, similar question, but just a little harder. As soon as it comes up. Okay, here we go. Negative 3 times 6y minus 3 plus 6y is equal to negative 3. So we got all kinds of stuff going on here. Does that look a little intimidating? Yeah. Well, you have to treat math problems sometimes like an elephant. How do you eat an elephant? One bite at a time, right? So we got to just do one thing at a time. So the first thing I want to notice here, oh, I got some parentheses. I got to get rid of the parentheses, and the way I get rid of parentheses most of the time is I do the distributive property. So negative 3 times 6, y, is negative 18y. Negative 3 times negative 3 becomes positive 9. Now the plus 6y comes down. And again, I got parentheses, so I'm going to do negative 3 times y. And negative 3 times positive 2 is a negative 6. Now, do I have some things that I can simplify? Right, well, I got these y's on the same side of the equal sign that I can simplify. A negative 18 and a positive 6 is a negative 12y plus 9 is equal. This side, I got nothing I can simplify, right? But now I got to get this negative 3y over here by doing the opposite. And now I got negative 9y plus 9 is equal to negative 6 because that's 0. So now here's my opposite. Sorry. That's maybe a little bit better. Do the opposite of adding 9, which is to subtract 9 on both sides. Always do the opposite of subtraction and addition first. This 9y stays there. That's 0. This is negative 15. Then I do the opposite of multiplication and division. And since this is multiplication, I'm going to divide by negative 9. Sometimes we might be tempted to make this a positive because we're like, oh, the opposite, the opposite, the opposite. But we're not doing the opposite number, we're doing the opposite operation. So the negative 9 stays there, we're just dividing it on both sides. And so my final answer is not 15 over 9. I have to simplify that. Oops, by dividing by 3 on both sides. I moved both the numerator and denominator. And so I got 5/3 or 1 and 2/3 is my answer. Okay. All right. Let's see. Next problem. We've already done that. We've done that. Let's do this one. Yeah, let's try this one. Okay. So this is going to be similar. All right, so negative 2y, because again, distributive property, negative 4 plus 7, distributive property again. Okay, combine some like terms. You know what? I don't like this problem. Scratch it. There we go. Scratch that. Let's do this one. Because that one was just going to give us the same type of thing we already did. So I want to show you something different. Okay, this will work better. So 4 times u plus 4 times 1, 3 times u, 3 times 1, whoops, got my u there, plus u. Okay, combine like terms now, right here. So 4u minus 3, because positive 4 and negative 7 is negative 3. 3u and 1u is 4u. Ha ha, 4u. But that's a 1u there, right? So 3u plus 1u is 4u minus 3. Oh, what happened? What do you notice? Yeah, they're exactly the same, right? And what that means, when one side equals exactly the other side, it means it doesn't matter what you plug in for u, you're gonna get the same answer. All right, you can plug in 20, you can plug in 7 billion, you can plug in negative 3/4, it doesn't matter. You're gonna get the same answer no matter what you plug in, okay? And so what we say for that is we say the answer is all real numbers. Yes, there are imaginary numbers, okay? But that's how we answer that when we get that situation, okay? Now, just so you can kind of see that there's something else out there, let me give you a little different situation here. Let's say that we work this problem out and instead we got this. Now, if I was to continue solving this by doing the opposite, oops, didn't want that, I'm sorry. I'd get negative 3 equals 8 because that's 0 and that's 0. Does negative 3 equal 8? And that's what you have to ask yourself, no. So that means the answer is no solution. What do you think? So in one case, when they were exactly the same, we got all real numbers are solutions. And in this case, where negative 3 does not equal 8, they do not equal exactly the same, but yet my variables went away, no solution. So be on the lookout for that problem. Don't just assume it's no solution. Okay, work it out, get your answer, go from there. Okay. All right, I think we have time for at least one more. Let's see what I can find for you. All right, let's do this. We're going to start off with this, and then we're going to kind of finish this up a little bit on Wednesday, next Wednesday. But this problem here has to do with absolute value. Okay, so this is absolute value symbols, right? We could put a number in there, but what absolute value measures is distance. Absolute value is measuring a distance, which is why you may have learned that absolute value makes things positive. Because we don't talk about numbers with a distance and say it has a negative distance, right? It always has a positive distance, okay? So that's one thing to keep in mind for absolute value. Now, there might be times where we put a variable in there and then we say what the distance is, right? So this is asking what numbers, right? Because that's what the variable really stands for, is what number has a distance of 5 from 0, okay? Now, you don't have to do this every time, but I'm just kind of showing you the how and the why this works. So if I start at 0, what numbers are 5 units from 0? Well, if I go 5 units this way, I get the number 5. But I can also go 5 units this way. It's the same distance, right? Distance doesn't matter whether we go left or right. But what do I end up with here? Well, I end up with negative 5. So when we have a question like this, we want to say x equals negative 5 or 5. Okay. Now, the only thing you have to be careful about here is if they happen to have, let's say we had something like this, okay, and asked us to solve. Well, in order to solve this, we have to get this absolute value here by itself. And so I'd have to get rid of this plus 5 by doing the opposite. Subtract 5, subtract 5. Have I said opposite enough yet? Because I'm trying to drive that home. okay? So now that's 0, right? But I still have the absolute value of x, but now I have -4. But what do we say about absolute value? What does it measure? It measures distance. Can we have a distance of -4? No. I don't even have to work that out. Anytime my absolute value is equal to a negative, it's automatically going to be no solution. There's no way to get a distance of negative. Okay, and I know what you're thinking. Well, can I go left? Well, that's a direction. That's not a distance. Okay, so keep that in mind. All right, that should get us through with the first couple of sections in our topics. Okay, some of you may be past that or whatever, but we'll get back to that. We'll get back to some more on Tuesday, Wednesday, and Thursday of next week. Okay, so I am going to have an optional class. I'm going to send an email about this on Tuesday morning at 10 o'clock. Okay, so maybe I'll see some of you guys then. But otherwise, that's it for today. Let me know if you have any questions. Thanks. Bye.